And now Yan is going to throw the die 60 times. Okay, so if I were to call Y to be the number of 6 that is shown on the die in 60 rows, that means Y over here, it will now follow a binomial distribution of 60 and 1 over 6. I'm supposed to use an approximation to find the probability that the number of 6 that I'm going to get is between 5 and 8 inclusive. Okay, to do an approximation, let's check the number of trials. Number of trials here is 60. This I will consider it as large. Then I'm going to check n times p. N times p is 60 multiplied by 1 over 6. 60 multiplied by 1 over 6 is 10. This is bigger than 5. And I'm going to check n times 1 minus p. So 60 multiplied by 1 minus 1 over 6. And this I'm going to be getting a 50. And this is also bigger than 5. Which means that this binomial distribution can be approximated to a normal distribution. And for that normal distribution, it is going to need an expectation of y, which I'm going to get from the binomial distribution here. It is n times p, 60 times 1 over 6, which is equal to 10. And I need to get the variance of y, which is n times p times 1 minus p. It is 60 times 1 over 6 times 1 minus 1 over 6. And this is equal to 25 over 3. Which means that y can now be approximated as a normal distribution with a mean of 10 and a variance of 25 over 3 approximately. And the probability that we are looking for is the probability that y is between 5 and 8 inclusive. So this, okay, inclusive. So bigger or equal to, less than or equal to. And since this is a discrete random variable being approximated to a continuous random variable, we need to carry out a continuity correction. So we are going to rewrite this as from 4.5 all the way to 8.5. We're making the area bigger by shifting the left and right limit to out by 0.5. And this is carrying out a continuity correction. And pressing this into my calculator by making use of a normal distribution, I'm going to get a probability of 0.273.